Dev here. I just want to talk about the networking code and game lobby system I've set up, along with a cloud saving system. So users can host games and have others join it pretty seamlessly. This game I just sort of coined as WizardsBattle, but I'll probably rename it to something better once I move along in the game production. So first up would be the lobby system. So here you can see the game hub system, which is kind of like a lobby system, except all the hosted games that are going on will be listed here, and you can join them assuming you have the join code. So I'll eventually add like a friends list, and I'll password protect the games so not just anybody can join. In this view, you can see all the buttons and all the text, but once we run the demo, you'll see that most of this is hidden away behind some logic. Once the game starts hosting, it'll actually pull up the loaded file. Now the loaded file is actually in the cloud. I have it under DigitalOcean right now, and it's literally just a JSON file. Anybody could technically download these if they knew the exact game ID. Each one is unique using a UUID v4. To show you an example of what it might look like, I'll open one up. So what you see here is just some JSON text, except some things, such as state, being like player position and rotation, velocity, things like that, will get saved as a byte array, which then gets converted to a hexadecimal display. So when we actually load the file later, we'll actually decode the hex and then put it back into a byte array and then load it into the game engine itself. The reason for all that confusion is because JSON doesn't support anything else, and it was actually really easy to keep it simple by keeping it as a hex-encoded string instead of just doing a byte array of everything. If I had to do byte encoding of the entire save structure, it'd actually be a lot of work on my end. So it's actually easier to just byte encode certain portions and encode them as hex strings, and then keep everything else as JSON, which makes it really easy to read and understand. And if you ever need to like make a change, we could pretty easily without having to load it into the game engine first. So here you can see it's actually on ready host, it's loading, it's ready to host the server. It's going to load the game and find all of the nodes that are in a persistent group and basically replace them. If it's not, then it's considered like a dynamic node, and they'll actually create them based on like the node path that was saved in the file structure. Here's a little node path example right here. Ironically, there's a hex encode, but there's not a hex decode option in Godot. I think there's just a pull request like a week ago where they're going to do that, but I found some code online that basically does that for me. Here we actually load the player's position. For testing purposes, I deactivated the setting the state of the player from what was saved in a file, and instead just do random positioning because I'm testing on a local computer, but when I use two different computers, I'll actually load the position of the player and save the position of the player. So each player is saved in a different location on the map. Here's what it looks like when I'm actually saving the game. I process this on an interval. I go through each of the parts of the player that I want to save. In this case, I'll take the sync state and I encode it. The reason why I take this sync state is because I'm actually pulling it from the network code that I'm also using. So it's actually kind of ideal to just use the exact same structure. I'll show you that in a second. I also take the camera rotation, which saves the player rotation in terms of network code. The player rotation is actually pulled from player input, which is based on the authority of the client, not the server. I'll go into that in a little more detail. Also, any items that the player has, which are all just currently just strings in an array, get saved to the game save. These items are saved in the game save process. After that, I actually call the game save. And on the back end, this makes a call to a Node.js server. I'll show you that in a second. So here's the game save functionality. I'm calling a REST method. I'm calling an HTTP method, a post method, to a backend server. It's a Node.js web server, basically. And I supply a few things I already set up during like the handshake process. There's a session token. There's also a game secret. Since this is HTTPS, I'm not too concerned about actually putting the secret in the header of the request, but normally you'd probably want to use something like an HMAC instead. I also, out of hope for durability, I encode the MD5 hash of the game save data, meaning I take the entire game save data string, which is a JSON string, and I get an MD5 hash from it. I use this information so on the server I can also check the hash of the data and make sure the entire JSON string was sent during the request. That way I don't cut off any game save data during the save request. I don't think it would actually happen in most cases, but I did it anyways just to be cautious. There's two parts to an HTTP request in Godot. One is making the request, and then the other is waiting for the response, and they're actually split up into two different functions. It makes it a little more difficult to track the state of your original request because it becomes a two-part thing. And so you're kind of waiting on the request, and it's called as like a callback, but you don't really have a good way of tracking it. I might reorganize this code a little bit differently so it's not so complicated to track the request. But for now, I sort of have it in a good state. So let me show you some of the sync state code. Over here is the sync state code. I use this primarily for network replication, but I'm also using it for game save data. The same thing goes for player input, as well as containers have a sync state as well. So as in like what position, what's the rotation? Because containers could be moved around and placed in different parts of the map. Here I add things like add to group persist, which will let the save function find all the persist nodes and then back them up, essentially. In addition to all the game saves, in this case I'm using a DigitalOcean Spaces, which is kind of like a blob storage or a bucket, if you will. It's very cheap, by the way. In addition to that, I also decided to work on a Node.js app using their app deployment system, which is actually really easy. Instead of having to set up a server and run the app manually, I set it up with their deployment program, which basically you point your repository to this, and every time you make a push to whatever repository that you are pointing it at, it will then rebuild the app and then redeploy it. So it's basically always up to date, and you don't have to do any sort of manual deployment process. Now, this app is what controls all of the game save states, but it also helps the Game Hub set up and track all of the servers in the lobby. Here's the backend for lobby storage. I'm using Azure Tables. It's super easy to work with. It's probably the easiest key value storage to work with out of any database system that I've found. It's a shame that DigitalOcean doesn't also offer something similar. They do have a Redis cluster that you could spin up, but it's $15 a month, and it would have taken me a lot longer to figure out because Redis is totally different than Azure Storage. So right now I'm just tracking very simple state of each game. Basically, the partition key is the game name itself, because I intend to use this for more than one game. The row key is the game that's being hosted, so there might be hundreds of hosted games at any point in time, and each one will have its own unique ID. The timestamp is when it was last updated, and then the creation date was when you originally hosted the server for the first time ever. The endpoint gets updated, so every time you host the server, you'll have a different endpoint, and there is the secret to hosting, the password to hosting your server is stored in a hashed value, and it gets checked every time you want to rehost your server. So someone would have to know your password, and they wouldn't be able to pull it from this database even if this database got hacked, because it's in a hashed state and you can't undo that. It's a one-way hash. So on the player side of things, each player gets spawned into the game once they join the hosted server, including the person that's hosting the server. For the player itself, player input is actually controlled by the client and not the server. This allows players to have, input codes such as like moving forward or jumping, but it also includes some other things like interaction and aiming. These are just simple RPC calls. They get called locally, so the logic is run locally, but it also gets run on the server, so then it can be synchronized across all the other player states. So I'm going to show you just an example of how this will actually run. When you first start up the executable, you'll connect to the hub and you'll get a session token, which will let you talk to the backend web server. In this case, I'm going to host the game, and there's only one game that I have saved so far. I could create another game and there'd be multiple games here. I don't have them named right now. They're just the unique IDs. I'll probably have them named and also have a second section of like the creation dates. You can kind of keep track of all your saved games. So I'm going to load this up. So right now I turned off where the player gets saved in terms of the world. I know it's a small world. In terms of the world where the player gets saved because I'm running it locally on 2 different computers. But in the future, I just have to flip a switch and then your player's state will actually get saved at a location as well. So before I load up the client, what I'm going to do is I'm going to show you what the server is doing, the hosted server. So once you start hosting, you load the cloud save and you disconnect from the game hub. This gets loaded in and pushed into each state. So in terms of player state, the player stats would be updated, or the player position, if I had to turn back on, would be updated, things like that. For the server to be hosted, I'm using Universal Plug and Play. Let me see if I have that file open anywhere. Here it is. It's really simple. It's basically the example that Godot has up on their site. Once this does get properly created and the random port gets created on your router, the Game Hub server is updated and the backend web server is updated with your random port that gets a stun server setup, so you wouldn't need to do UPnP, but in Godot 4 it seems to be not possible anymore. I tried for hours and hours trying to get it to work, and I eventually just discarded it and just set up a UPnP instead. I have a little bit more work to do, such as if UPnP doesn't work, what you should do is probably set up your own port forwarding on your router, and I could have basic instructions on that, and then you could enter in the port information on the start section of the menu. So in this instance, I'm going to have this be the client. So when it joins, it shows all the games that are being currently hosted on the Game Hub. In this case, it's just one game that's being hosted on the Game Hub. It goes through the joining process, and then the character shows up. So now both characters will be saved during this process. Let me bring this back down. So just for fun, I decided to be able to throw potions around just to make sure I could sync state. This is a rigid body that's being synced between the two computers. It's a little bit laggy on the client side, and I think it's because I'm frame for frame updating its location, where instead of updating its location every other frame and then interpolating it with the physics system itself. And I'll probably update that later on. I don't plan on having too many rigid bodies being synced across the network anyway, so it's not really a big deal. So as you can see, different states are being synced across the network, as well as rigid bodies and locomotion being synced across the network. I also have containers. So right now I've used the inventory button and it shows you what you have in your inventory, which in this case is nothing. But in this barrel is some things you can pick up. So if you look down at the bottom, you can see items found, apples, and apple. So if we walk away and then check our inventory, we've picked up apples, the first thing that was in that list. If we go back, we can see we now have 2 items in our list, apples and apple. Now, since it says cloud save complete, you can see now that there's nothing left in the crate. And if we go look at the cloud save itself, it'll be empty on the crate. I'll show you that now. So I pulled up the game save data for this game, and you can see in here, under barrel, there are no items left. When before there were items inside the barrels, apples and an apple. And now this player right here, which is the current player over here, now has apples and apple in their inventory. So it's just a really basic save system. But the benefit is it gets to be in the cloud. And so whoever starts hosting the game first, it could be either the client or the original person that hosted the game. Whoever starts hosting the game first can then load up the cloud save and then continue saving back to the cloud. So the idea is that you don't need to wait for your friend to host the game for you to continue playing that same game, and then they can join you later. So that's just sort of the gist of it. I just wanted to go through everything I've been working on for WizardsBattle. It's come along pretty great. It has a lot of game mechanics I need to fill out. I need to work on some spells and obviously level design. There's not much here. I have started working on creating better textures for the grass. This is using a macro texture, and another macro texture that kind of creates darker areas, and then the actual grass texture itself. And which the point of that is it can help reduce repeating textures along with mip mapping. You can't really notice that this is literally just one small texture. This is even a good texture I found. So these kind of techniques help a lot for terrain. All right, that's it. I hope you found this interesting. I plan to do a lot more networking code, but I think the next video I do will probably be about mechanics and some actual design elements. And I may do a follow-up networking video as well down the line.